help me, help me. Yo, freaking help me. Help me, I'm dying.
Oh my god, I gotta come.
Yo guys, what are you doing? Turn off my Xbox. We're supposed to be doing our chem project.
Yo, man, shut up for a second. One more kill, almost got.
It's due Wednesday.
Yo, man, shut up. Rules got this. Wait.
Yo!
Wow,
you pansy.
Man.
Alright. So, do you guys have any ideas?
Well, I have a great...
I didn't ask you. What about you, Mom?
Man, I had some ideas, but they're pretty lame. I don't know. What about you?
Hi, I'm Momer the Scientist, and today we'll be talking about electrons. Welcome to the laboratory. Now, let's discuss reactivity. Reactivity is the ability of an atom to react to another atom. Let's go make some observations.
Reactivity of metals. Reactivity of metals decreases as you go to the left and increases as you move down. There are firstly less valence electrons, so it's easier to lose them when moving to the left. The reactivity increases as you move down because the valence electron is farther away from the nucleus and has less pull on it. Reactivity of nonmetals. Reactivity increases as you go to the left for nonmetals and increases up for the nonmetals. This is because as you go to the left, the element is closer to the complete valence shell, and when going up, as the atom has a tighter hold on a valence electron.
Lithium also has one valence electron, but since it is higher up in the periodic table, it's less reactive. Potassium, because it has only one valence electron, is very reactive. Let's see what happens when you mix it with water. Kaboom! Now let's talk about nonmetals. The more valence electrons they have, the more reactive they are.
Let's compare helium as a full valence shell.
Hell no.
First, we will be talking about ionization energy. It's the amount of energy an atom needs to lose its last electron. Let's take a look.
Ionization. Ionization energy increases as you are going to the right of the periodic table, and increases as you are going up. This is because as you go to the right, there are more valence electrons, and it is harder to remove them. As you move up a group, the atomic radius size decreases, and so each electron is held even more tightly.
Lithium is an element with a very low ionization energy. It can lose its last electron very easily. Carbon has a decent amount of ionization energy. It could lose its electron, but it does put up a bit of a fight. Fluorine has a very high ionization energy. It is very difficult for it to lose its last electron. Fight!
Finish him!
This is fluorine!
Fatality.
Electronegativity is the measurement of an atom's ability to attract and share another electron.
Electronegativity. Electronegativity increases as you move across the period to the right, as the element has more valence electrons and wants to share them more to reach its octet. Electronegativity increases as you move up a group because the electrons are held into more tightly, and so it is much easier to gain them.
Lithium has a very low electronegativity. It does not want to attract or share electrons. Carbon has a decent amount of electronegativity. It doesn't mind sharing or gaining electrons. As for fluorine, it has a very high electronegativity. It loves to share and attract other electrons.
I love you, you love me, we're a happy family with...
Electron affinity is a change in energy that occurs when an atom gains an electron.
Electron affinity. Electron affinity generally becomes smaller as we go down a column of the periodic table for two reasons. First, the electron being added to the atom is placed in a larger orbital, where it spends less time near the nucleus of the atom. Secondly, the number of the electrons on the atom increases as we go down a column, so the force of the repulsion between the electron being added and the electron already present on a neutral atom becomes larger.
Now let's take a look at beryllium. It has a low electron affinity, therefore it absorbs a lot of energy. Now let's take a look at calcium. Compared to beryllium, it has a higher electron affinity, therefore it absorbs less energy. Now we take a look at carbon. It has a lower electron affinity, therefore it releases less energy. Here we have an example of fluorine, which has a high electron affinity. Therefore, it releases a lot of energy, which resembles its change in energy.